Hello students, welcome back to the Tantray physics classes. Here we have one more problem on magnetic effects of current, and the problem is good for IIT aspirants and those who want to go for physics Olympiad. The problem is like this: it is an inclined plane with an angle of inclination theta, and magnetic field is perpendicular to the base of the plane, and a rod is moving down the plane with constant velocity. Of course, there is a force, gravitational force, it should accelerate, but this magnetic field also creates a force, and with magnetic force and gravitational force, the rod moves with a constant velocity down the plane. तो हमें देखना है कि कितना magnetic field होना चाहिए so that the rod moves downwards with a constant velocity. What is the magnitude? Magnitude of velocity, magnetic field, so that rod moves along the plane with constant velocity. ये है क्वेश्चन. ये मैग्नेटिक फील्ड कितना होना चाहिए ताकि ये रॉड जो है इट मूव्स विद अ कांस्टेंट वेलोसिटी. तो क्या होता है, व्हेन द रॉड बिगिंस टू मूव, द फ्लक्स थ्रू दिस पार्ट ऑफ द circuit changes. When the flux changes, there is induced EMF. When there is an induced EMF in the rod, it sends current through the resistor, and that current passes through the rod itself. And now the rod is in the magnetic field. When the rod is in the magnetic field, there is a force on the rod, and we have to find direction of force. And there is a component of that force up the plane in this direction. So if that component of magnetic force balances the gravitational force, that is mg sin theta, of course, because अगर rod का mass m है तो it is mg sin theta along the plane, gravitational force, because mg is downwards, उसका component होगा along the plane. So when this force, magnetic force up the plane, equals the gravitational force down along the plane, if they are equal, अगर वो equal है तब जाकर rod will move with a constant velocity. So gravitational force along the plane downwards should be equal to magnetic force along the plane upwards. When we equate those two forces, and then we have the condition, we have to find magnetic field so that it moves with a constant velocity. Well, that simply means we have to equate magnetic force with this gravitational force. तो पहले तो मुझे यही देखना है कि induced EMF किसके बराबर है. तो induced EMF is equal to, तो किसके बराबर होगा? VBL, as you know, VBL, मगर वो तब था जब when magnetic field is perpendicular to the plane of the loop. यहां मैग्नेटिक फील्ड लूप के परपेंडिकुलर में नहीं है, वो एंगल बनाते हैं. ये मैग्नेटिक फील्ड है, दिस इज मैग्नेटिक फील्ड. तो मैग्नेटिक फील्ड वेलोसिटी के साथ परपेंडिकुलर नहीं है. I mean, this magnetic field is not perpendicular to this velocity. It is perpendicular to the base. So there is an angle between velocity and magnetic field. What is that angle? This one. This is the velocity direction. This is magnetic field. That is 90 minus theta. तो what is the induced EMF? तो उसका जनरल फॉर्मूला है V क्रॉस B डॉट L. जनरल फॉर्मूला, जब ये V, B और L आपस में एंगल्स जो है 90 नहीं बनाते हैं, तो ये जनरल फॉर्मूला है. तो induced EMF is VB, what is the angle between the two? That is sine of 90 minus theta into L. क्योंकि V क्रॉस B जो है, V क्रॉस it is B, V क्रॉस B का डायरेक्शन वही है जो L का है. सो डॉट खत्म हो जाएगा. V क्रॉस B का वही डायरेक्शन है जो L का है, इसलिए डॉट खत्म हो जाएगा. सो इंड्यूस्ड EMF इज VBL, तो ये हुआ cos थीटा. नाउ व्हाट इज करंट? करंट इज इक्वल टू E by R. Induced EMF, it sends current like this by R. So it is VBL cos theta by R. ये है हमारा करंट. And this current passes through this conductor. Now it is a current carrying conductor in the magnetic field. तो उस सूरत में what is the force on the conductor? How much is the force? It is the current carrying conductor in the magnetic field, and we have to find how much is the force, and we know the formula. The formula is FM is equal to ILB. IL क्रॉस B है, लेकिन L और B में एंगल 90 है, L and B में एंगल 90 है. So it is I, what is I? VBL cos theta by R LB. So FM is equal to VB square L square cos theta by R. अब देखना यह है कि इस मैग्नेटिक फोर्स का जो डायरेक्शन, वो डायरेक्शन क्या है? What is the direction of this magnetic force? That's very important. अगर आप यहां ये करोगे कि ये मैग्नेटिक फोर्स इस mg sin थीटा के बराबर लिखोगे तो गलत होगा, क्योंकि ये जो मैग्नेटिक फोर्स है, मैग्नेटिक फोर्स का डायरेक्शन है L क्रॉस B. अगर आप इस L को B के साथ क्रॉस करोगे, इस L को इस B के साथ क्रॉस करोगे, वो एक डायरेक्शन आएगा, वो डायरेक्शन ये नहीं आएगा, वो डायरेक्शन ये आएगा इनवर्ड्स. दैट आल्सो मेक्स एंगल थीटा हियर. तो इस मैग्नेटिक, ये है ये मैग्नेटिक फोर्स, लेकिन अब इस मैग्नेटिक फोर्स का कंपोनेंट जो इस ओर आएगा, दैट वी नीड, दिस वन, दिस कंपोनेंट वी नीड. सो नाउ दैट कंपोनेंट, इस मैग्नेटिक फोर्स का ये कंपोनेंट इसके साथ बैलेंस होना चाहिए, ताकि इट विल, द रॉड विल मूव डाउनवर्ड्स विद अ कांस्टेंट वेलोसिटी. सो for constant velocity, we have a condition. What is that condition? FM cos of theta. इस फोर्स का ये कंपोनेंट, लेकिन ये फोर्स इस प्लेन में नहीं है, देखो ये इनवर्ड्स करना है ये फोर्स. इट मेक्स थीटा विद दिस, विद द हॉरिजॉन्टल डायरेक्शन, inverse horizontal direction, and then you get the component. So FM cos theta is equal to how much? Mg sin theta. So FM is what? V B square L square cos theta by R into cos theta again square Mg sin theta. तो अब B square किसके बराबर? B square is equal to Mg sin theta divided by VL square cos square theta, VL square cos square theta नीचे, और ये R यहां मल्टीप्लाई होगा. तो B किसके बराबर है? B, शाबाश, that is root of RMG sin theta by VL square cos square theta. VL square cos square theta ये. तो जब आप सबस्टिट्यूट करोगे, R is 1 ohm, M is given to be 1 kg, G is 10, sin of 21, V 1 meter per second, L length of the rod, रॉड का लेंथ भी दिया है 1 मीटर. तो जब ये सारे चीजें आप सबस्टिट्यूट करोगे, so B will come out with 1 Tesla, that you can check out. So we need 1 Tesla of magnetic field perpendicular to the plane of the perpendicular to the base of the incline, so that the rod moves downwards with constant velocity. So basically it is an incline on which a rod moves down, but there is a magnetic field. When the rod moves down, there is a frame, wire frame, on which the rod moves downwards, which is fitted on the inclined plane. When the rod moves down, the flux changes. The moment flux changes, induces the EMF. That sends current. And then current moves through the rod. When current moves through the rod, now the current carrying rod is in the magnetic field. So there will be a force. That force is, if I show you, that force is, this is the rod moving down like this. But force on the rod is not like this. It is like this. Force on the rod. This is the rod, but this is force. So हमें इस force का ये वाला component लेना है. This component is equal to this component. This is mg sin theta. This is fm cos theta. This is mg sin theta. This is fm cos theta. If we balance the two forces, then the rod will move down with a constant velocity. This is a problem for the IIT aspirants or for those who want to go for this physics Olympiad, and continue to watch my lectures on YouTube and download my app from the Google Store. Also, don't forget to watch my lectures on the YouTube. Thank you.